All right, next we have a problem that's very similar to the one that we just saw. Prove the statement using the epsilon-delta definition of a limit. The statement is that the limit as x approaches 10 of 3 minus 4/5 x is equal to negative 5. We're given the limit here. Here we're told that the limit is equal to negative 5. I see here that f of x is equal to 3 minus 4/5 x. And then in the limit statement, as x approaches 10, well, that tells me that a is equal to 10. Now, folks, the epsilon-delta definition of a limit has, for every epsilon greater than 0, there is a delta greater than 0, such that if x minus a is between, strictly between, so not or equal to, 0 and delta in absolute value, then the absolute value of f of x minus L should be less than epsilon. So, I mean, we have like an if, right? So there are other words here, but what we're really after is for every epsilon I can find a delta, and we have these inequalities. Now, as before, we're going to start with the epsilon inequality. So 3 minus 4/5 x in absolute value minus a negative 5, right? So that's our f of x minus L is less than epsilon. This is the beginning of our exploration. And we'll just see what happens when we simplify inside the absolute value. I have negative 4/5 x plus 8 is less than epsilon. And then inside here, I'm going to factor out a negative 4/5 inside the absolute value. So negative 4/5 times the quantity of x. Now what happens if I take 8 and I divide it by 4/5? Well, that's the same thing as taking 8 and multiplying it by 5/4, right? Because, look, I'm looking at division because factoring looks a whole lot like division, right? So that's going to be what? 40 over 4, that's 10. And the 4/5 was negative. So absolute value, negative 4/5 times the quantity of x minus 10, whoops, parenthesis, and then absolute value is less than epsilon. Well, look at this. I have my x minus a right there. So before we said we can factor out a positive number from an absolute value. Well, look, an absolute value of negative 4/5 is 4/5. So I can factor out 4/5. And I have 4/5 times the absolute value of x minus 10 is less than epsilon, which means that the absolute value of x minus 10 is less than 5/4 epsilon. Well, what I've just built is an inequality that involves x minus a and 5/4 epsilon. That tells me that 5/4 epsilon is equal to delta. Folks, all of that was explore, and I did all that just so I knew how delta relates to epsilon. What happens next? It feels like you're not really doing anything, but it's how the problem proceeds. And it starts like this. So this is the beginning of the answer. If delta is equal to 5/4 epsilon, then, and then folks, what we end up doing is we start with the absolute value of x minus 10 is less than delta, implies that the absolute value of x minus 10 is less than 5/4 epsilon. And then from here, folks, we do all the algebraic steps that got us to this point, but we do them in reverse. So 4/5 times the absolute value of x minus 10 would be less than epsilon, which means that the absolute value of negative 4/5. Now, how do I know to write all that? Because we already did it. I'm just writing all the steps down in reverse. So the absolute value of negative 4/5 x plus 8 is less than epsilon, which means it's the absolute value of 3 minus 4/5 x minus a negative 5 is less than epsilon, which I guess we can say then means that the absolute value of f of x minus L will be less than epsilon. So the definition says if for every epsilon there's a delta, blah, 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 then if delta is equal to 5/4 epsilon, which means you tell me what epsilon is, I'll be able to tell you what delta is, then all this algebra tells me that the function value will be within epsilon of -5. And folks, that's how these problems are done.